All right, this is part two of the midterm review number three. Okay, we're going to continue here with number 10. So determine if the inverse is a function. What do you remember about inverses? We switch x and y. Feel free if you would like to. You can actually come up with the table for an inverse like this. So we're switching x and y. So that's 2, -1. All right, 4, 0. -2, 5. And let's see, 5, 8. And 4, 9. Okay, and what we're looking for, determine if the inverse is a function. Well, remember, if something's a function, x doesn't repeat. All right, so right here, this is the inverse. Is it a function? And what we want to look at is our x values. Do any of our x values repeat? And it does right here. Whoops. The fours repeat. The other way we could look at it is right here. If we just look at this and knowing that the inverse switches x and y, if I just look at the y values right here, if I see any of the y values repeat, then we know the inverse is not a function. So the inverse is not a function because there is blank 1 and blank, because there is not 1x that maps to one y value. All right. It could also be one domain value that maps to one range value as well. All right. And here, these questions are also off of it as well. So f of 5. Okay, f of 5. Here, when we're talking about f or g, and it's just this number right here, this is the x value. So here, x at 5 is -2. So that comes out to be -2. But when we're looking for the inverse at 5, and this is not the table of the inverse, then this is the y value. All right, so I go to 5 here and the y value, and I see that value is 8. Now, if you have drawn the table and it is the inverse, then yes, you do take that 5 as the x value, and you see that it's the inverse is 8. So just be careful whether they're giving you a table of the inverse or not. All right, number 11 right here. Rotate the following two-dimensional object around the x-axis. All right, I'm going to do that first. And remember, rotate, what you want to do is you want to basically reflect it, but then rotate, think, what type of motion am I making? I'm making a circular motion. So let's put a little 3D shape to it. And it's going to make it three-dimensional. So don't say it makes a circle. What does it actually make? It makes a sphere. All right, so we made a sphere here. Suppose each square is worth 2 square units. All right, so be careful on this right here. Each square is worth 2 square units. If it gave 1 square units, we can just count by ones. But here we're going to have to count by twos. Find the volume of the three-dimensional object. Well, we got several things going on here. Well, first off, a sphere. What is the volume of a sphere? You got to remember all those formulas, so please have them memorized, okay? 4/3 pi r cubed, like that. All right, so here, 4/3 pi, you got to know the radius. Well, here we think it's going to be 3, but because each square is worth 2 square units, it's going to be 2, 4, 6. All right, so our radius equals 6 here. So 6 cubed. All right, now it didn't specify, but let's go talk about, okay, in terms of pi versus a decimal. All right, here, if I ever ask you in terms of pi, what we can do is we can take, and let me go grab Desmos right quick. We can take Desmos and you only put in the numbers. So if I want pi in my answer, I only put in the numbers. I know that sounds really weird. So 4/3, okay, I just typed it. And then you put in 6 cubed. Now, if you're trying to put in cubed here, some of you know that caret symbol if you do shift 6, or you do this A to the B and then you type 3. Okay, so it comes out to be 288. Now, and 288, and we would put pi with it. I'm just going to write it down on my paper, and then I'll show you in a second. Now, if you're trying to, if it ever says to the nearest tenths, to the hundredths, tenths would be 1 decimal place, hundredths would be 2 decimal places, thousands would be 3 decimal places. What we do is we add pi in there, and you can just type in pi, or the pi button is down here. Okay, so our answer, say if I round it to the nearest tenth, tenths is 1 decimal place. So I look here to the second decimal place, it's a 7. So this 7 is going to go to an 8. So it's going to be 904.8. All right. So you can see what it looks like here. All right. So this is in terms of pi, 288 pi, only put the numbers in. This is as a decimal. So it depends on what they're asking for. So just be very careful. All right, moving on to number 12. Okay, label each relative minimum on the graph. We'll start there. So minimums, it goes down, so it decreases and then increases. All right, so where are some minimums? It appears a minimum is right here. We'll just say, I'm going to approximate this. It looks like it's at -2, -7. Okay, so -2, -7. All right, I have another minimum right here at 2, 0. Always put the x value first. Okay, so I have two minimums right here. It goes down and then it comes back up. All right, now label each relative max on the graph. Okay, and I'll do this. This one's min. Okay, max is this time that goes up and then comes down. It's got that peak to it. So I've got a max right here at 0, 3. Remember, you put the x values first. The x value is 0, and then the y value is 3. All right, here's another max right here. I'm going to approximate that as 3.5 and 2. Like that. So be able to identify relative max and mins. Okay, now let's write an equation for this. Okay, so if I'm writing an equation, I've got to look for the x-intercepts first. Here, x-intercept is -3, so a factor is the opposite, x plus 3. -1, so x plus 1 is a factor. +2, x minus 2 is a factor. And +4, so x minus 4 is a factor. All right, now here's the problem. You don't know if there is a k value right there. All right, have we been multiplying it by something? So we use another point that is not an x-intercept. And you can use any of these maximums. A lot of times the y-intercept, as long as it's not 0, 0, is a great one to use. So that's what I'm going to use. I'm going to use 0, 3. So x is 0, y is 3. All right, so that's what I'm going to plug in. So when I plug in x is 0, I'm just left with 3 right there. Then I'm left with a 1. 0 minus 2 is -2, and 0 minus 4 is -4. So all of these things right here get multiplied. 3 times -2, or 3 times 1 is 3, times -2 is -6. -6 times -4 is a +24. And then how do I solve for k? You divide by 24. Oh, and guess what? I'm missing something. Okay. And here's how I knew I was missing something. I was about to get, when I divided by the 24, if you look at it, I was about to get a positive number, but this end isn't positive, it's negative. So I know this number needs to be negative. Well, what do you think I missed? Did you notice that this is a double root right here? The reason why it's a double root is because it bounces off the graph. So I'm going to go back and remember, you need two x minus 2's. So I'm going to put a square right here. Got to put a square there. So this number actually changes right here. And if you ever just want to throw it into a calculator, feel free to. So we're going to have, let's see, 3 times 1 times -2, but make sure you square it. All right, or you do times -2 twice, and then times -4. So this comes out to be -48. Okay, now how do I get k by itself? Please do not say subtract or add. This is multiplied, k times -48, so the opposite of multiplication is division. So we divide by -48 right here. Okay, now this does reduce. If I'm using my calculator to reduce right here, You can do alpha x 3 divided by negative 48, press enter, and it's negative 1/16. Okay, so k equals negative 1/16. So our equations, y equals negative 1/16, and then x plus 3, x plus 1. All right, x minus 2, don't forget the square, and I'm just going to squeeze this right here, x minus 4. So there is our equation right there for it. Now, if you're using Desmos to actually simplify that right there, then let's see. What we do is 3 divided by 48. And then you can hit this right here. Now, I know I didn't put the negative in there, but just realize it is negative. All right. Let's go back to our page. We had a couple more questions on here. Name the x-intercept. Okay, the x or the y-intercept. The y-intercept, we already did this, was 0, 3. Name the x-intercepts. Okay, the x-intercepts are negative 3, negative 1, 2, and 4. And we talked about those when we wrote the equation of the polynomial because you need those then. All right, moving right along. Now, these next ones come from Unit 4, and you've got to know how to factor. Now, you've worked on factoring with your calculators. If you want to use that, you can. I'm going to focus more on let's do this by hand right now. So if I didn't know how to factor this, I would factor and find the x-intercepts, and I would do the opposite. All right, but here, the factors of 5 that add to 4. I don't have any. Okay. Because the factors of 5 are 5 and 1. All right. And that adds to 6. And if I change the signs on those, it's going to add to negative 6. All right. So that actually does not factor. X squared plus 4x plus 5. All right. Now, x squared minus 4 is a perfect square. So the factors, so square root of x squared is x and x. Square root of 4 is 2 and 2. One's a plus, one's a minus. All right. Now, I'm going to go ahead and do two things at once. If it's division, you change it to multiplication, and then this flips. So this 4x minus 8 is going to go up here, but I'm going to factor it at the same time. What type of factoring do you notice here? Do you realize 4 goes into 8 and 4? So here, if I take a 4 out, all right, I'm going to be left with x minus 2 because 8 divided by 4 is 2. All right, there we go. Okay, now 3x plus 5, same thing, GCF. All right, a 3 goes into 3 and 15, so I pull out the 3 and I'm left with x, and 15 divided by 3 is 5. All right, see if it, make sure if anything cancels numerator and denominator right here. So x minus 2, and then I look at it. And nothing else cancels. So up top, I'm going to have 4 parentheses, x squared plus 4x plus 5. They may distribute the 4 right there. And then x plus 2, I'm going to put the 3 out in front, and then x plus 5. Now, if I want to double check this, I can always go to Desmos. All right, always plug in the original. Make sure if it has anything like Y's or whatever, you can change it. You need to have X's in there. Now, if this is multiple choice, okay, and you don't know how to factor, then my suggestion would be to graph all your answer choices. Okay, now divided by, notice it doesn't have that little division symbol. It actually goes all the way underneath, okay, and that's fine. All right, 3x plus 15, and I like putting the parentheses around the numerator and then dividing. Otherwise, you have to highlight it. All right, so here we go. There was the original problem, and then our answer for parentheses x squared plus 4x plus 5. All right, divided by 3x plus 2, and then x plus 5. And they could always multiply these out. And how do I know I did this correctly? If you notice, there's only one graph. Like if I didn't have this 4 right here, you'll notice it's two different graphs right there. All right, Now, moving right along to the next problem. Okay, now here, when we're adding and subtracting rational functions, you got to have a common denominator. All right, so here, do not break this apart, please. All right, put parentheses around each one of these. All right, the x minus 2 goes together, the x plus 5. They're totally different. And if you notice, this one needs an x plus 5. And whatever you do in the denominator, you do in the numerator. All right, this one needs an x minus 2. Okay, so our common denominator here is x plus 5, x minus 2. Now we need to work on the numerator. Okay, now my suggestion here is go ahead and distribute the 2. So that's 2x, and then 2 times 5 is 10. Now, be careful, you have this minus sign. Let's change it to a plus, and I'm going to put the negative on the 3. So I'm distributing a negative 3 right here. Negative 3 times x is negative 3x, and then negative 3 times negative 2 is positive 6. All right, so 2x minus 3x is negative x. All right, 10 plus 6 is 16. All right, x plus 5 and x minus 2. The only other thing you need to make sure that you do is that you factor the numerator if it's factorable. This one is not. The other thing is if you don't distribute the 2 and the negative 3 here, you'll put 2 parentheses x plus 5 and then minus 3 parentheses x minus 2, and you'll want to cancel the x plus 5 and x minus 2, and you don't want to do that. So that's why you want to go ahead and distribute. And just like we did the last problem, yes, you can graph it to see if you did this correctly. So put the original 2 over x minus 2, all right, minus 3 over x plus 5. And then we put our answer, negative x plus 16. And guys, right here, I didn't put parentheses, so you would have to highlight it and then do your division. And then x plus 5 and x minus 2. Like that. And we noticed that they are the same graph, so we did it correctly. The only thing is, if there's something that factors out and cancels with the denominator, it's not going to show that and it's going to look like it's correct. So that's the only thing I hesitate sometimes when you're graphing, because you want the simplest form. Okay, so if you run across two answers and it says what's the simplest form, then what you need to do is take the one that looks simpler. All right, it looks like it's actually been reduced the most. All right, now number 14, solve the following equation. All right, when we're solving equations, yes, you can do this by hand, 4 times that. So I'm going to do 4a, and you do 4 times 3, which is 12. All right, negative 2 times a is negative 2a squared. Negative 2 times a is positive 7a, like that. Now, if you're, or 14, I'm sorry, because negative 2 times negative 7 is positive 14. All right. If you recognize this as a quadratic, move everything over. I'm going to move it over so this a squared is positive. So that's 2a squared. When I subtract the 14a, I get negative 10a, and then I have a positive 12 equals 0. Do you notice how 2 goes into all of them? So we can divide everything through by 2, and that 2 just kind of goes away. A squared minus 5a plus 6. And let's see if we can factor this. All right, a and a, factors of 6, that give me negative 5. Well, that's negative 2 and negative 3. Don't do negative 6 and 1, because negative 6 times 1 is negative 6, not positive 6. All right, and now I set these equal to 0. A minus 2 equal to 0, a minus 3 equal to 0, and I would add 2. All right, a equals 2, add 3, a equals 3. So I have two solutions, 2 and 3. Here's the only thing. Make sure these numbers right here doesn't make any of the denominators equal to 0. So if I plug 2 into here, 2 minus 7 doesn't make 0, or 2 plus 3 doesn't make 0. Same thing here, 3 minus 7, I'm good. 3 plus 3, I'm good. It doesn't make 0. If it did, that's where we would have extraneous solutions. Now, extraneous solutions, that's the only issue with graphing it. You wouldn't really be able to see it. Now, let's see. if I go to my calculator, yes, you can solve these in your calculator. Now it does have a, so make sure you put x's in. X minus 7. And we press enter whenever we see equals. Put the other side of the equation, negative 2x divided by x plus 3. Okay, and we're looking for the intersections. All right, and if you actually looked, hold on, the two intersections are actually right here. Okay, when I hit it here, there's a gray dot, and here's a gray dot. And we notice 2 and 3. Aren't those our two solutions that we got? All right. Moving right along, we have one more. Name the discontinuities and their type. And what I mean by that is it a vertical asymptote? Is it a horizontal asymptote? Do I have a hole? Stuff like that. Okay, so let's start off with our horizontal asymptotes. Horizontal asymptotes come when we're looking at the degree. Well, when the degrees are the same, all right, before we start factoring anything, degrees are the same, then our horizontal asymptote, we divide our leading coefficients. So 1 divided by 1 is y equals 1. And I'll show you this on the calculator in just a second. Okay, now here, to find our holes in vertical asymptotes, we need to be able to factor. All right, nothing's out in front of x squared, so x and x. The factors of 6 that add to 5 are 2 and 3. All right, and here the factors of negative 6 that add to negative 1 are negative 3 and positive 2. Okay, now holes in vertical asymptotes come from the denominator. So x minus 3, set that equal to 0. X plus 2, set that equal to 0. Add our 3, so x equals 3. Notice I'm doing this before I cancel anything because some of you are itching and saying, oh, but you can cancel the x plus 2's. Well, yes, you can. So what does that mean about this x equals negative 2? It's a hole, or we also call that a point of discontinuity. Okay. And then this one didn't cancel. So what is that? That is a vertical asymptote. Now, can you see these on a graph? Yes. If you didn't know how to factor, yes, you can. You can see these on a graph. So if I take this and I put the original problem in, it is x squared, okay, plus 5x plus 6, and then I do x squared, all right, minus x minus 6, like that. All right, zoom out on it. I'm going to close the keyboard for a second. Zoom out. All right, and then here it appears that we could do one of those vertical dotted lines right here, all right, at x equals 3. And so I suggest type in x equals 3. Or even if you get the answers on your own like we did, you can double check it. And it looks like the vertical asymptote is at x equals 3. All right, it looks like we have a horizontal asymptote right here at 1. And remember, those are y equals. All right, and look, that we did write that earlier, and it's not crossing. If you need to zoom out further, feel free. All right, there's our horizontal asymptotes. Now, if you're not factoring it and you're just trying to do this by graphing, your holes are going to be the hardest to find. Okay, and that's taking this and going, you really need to go slowly, and you're looking for where the y value is undefined. Okay, I didn't see anything here. All right, and I'll be honest, if you go too quick, you may not see it. All right, and I'm not seeing it, but when I did it by hand, I got it at negative 2. So let's go back to negative 2 right here. Negative 2 is going to be here. And if you look, there you go, it's undefined. But I didn't find that in the first place. So you have to be very, very careful right there. But I do have a hole. When it says undefined, it doesn't, I can't draw the dotted lines for the vertical and horizontal asymptotes there. All right, and I actually do see a hole. All right. We've gone through all these reviews, so make sure that you are studying for your midterm. Make sure you cover everything that was all in units 1 through 4, and ask your teacher if you have any questions at all.